Hello guys, am I audible? Okay, I can see myself. So, how are you doing today guys? How's everything going? How was today's contest? How many problems you solved? Worst contest? Let me bring... Mess up on E. I see. Okay, awesome. So, shall we start discussing the problems? Shall we start from problem A now? I see. So today we will discuss all of the problems, and I think that definitely relative to Div 1 contest and Div 2 contests, it was a bit easier, but maybe not that easy. So, okay, let's start discussing. Oh shit, echo. Do I have echo? If everything is fine, I think we can start discussing the problems. Okay, so if it is fine, so let's go. Let's start. So, and maybe my voice might be low, so let me also increase my voice. This always happens. I think now it's better. And let me know if there was any issue, echo or anything like that. How can I have echo? Do I still have echo? So if you just give me okay, I will start discussing problem A. Volume is also okay or not? Okay, so if everything is okay, let's start discussing problem A. So, primary task, problem A. It says that Dimitri wrote down t integers on the board, and that is good. He's sure that he lost an important integer n among them. And the integer is of the form 10 to the power of x, 10 raised to the power of x, where this denotes exponentiation. And something went wrong, and Dimitri missed this symbol when writing the important integer. For example, instead of 10 to the power of 5, 10 to the 5th, he wrote 105. And Dimitri wants to understand which of the integers on the board could have been that important integer that he has lost. So we have to take a look at these numbers, and we see that if they are 10 to the power of something or not. For example, on this one, we have 10 to the power of 0, which is not one of the cases because x must be at least 2. So the answer to this one is no. This one is like 10 to the power of 10, so the answer to it is yes. This is 10 to the power of 1, so it is no, because we saw that x is at least 2. This is 10 to the power of 5th, it's okay. This cannot be seen as 10 to the power of something, so this is no. So this problem is somehow similar to, some sort of just an implementation problem. So you just need to know that let's take this number as a string. It's like we have a string s, and we see an s. I can just say that my string should be of this form. The first two characters must be 1, 0, because it must be like 10 to the power of something. So the first two characters must be 1, 0, and then after that we must have a number, we must have a valid number, and by valid number I mean that, for example, we cannot have leading zeros, no leading zeros. Wait a second, what has happened in here? Sorry for this. I don't know why this has happened. So we must see in S, and then in input we must have our first two characters must be 10, and then after that we might have a valid number, I mean without any leading zeros, and then this number must be at least 2. So it's easy to check. We just see in S, first we can say that if, for example, S of 0, for example, if we can both say it like this, S dot substr of 0 and 2 equal 10, this must happen. Or we can say that S of 0 equal to 1 and S of 1 equal to 0. Both works. So anyway, if it was not like this, for example, you can say that if it was not like this, then the answer is definitely no. Otherwise, we can just check S dot substr of starting from index 2, and the length can be S dot size minus 2. Hi. So it can be like this. And therefore in here we should just check that. In this check we must just check if there are no leading zeros. By no leading zeros I mean that if, let's call this as a string t, let's say that t is equal to this, t of 0 should not be equal to 0. If t of 0 was 0, then just return no. Otherwise, if t dot size was 1 and t of 0 was 1, it means that this exponential part is 1, which is again bad, so it's no. Else it is yes. The answer is yes, because we have a number with no leading zeros and this number is greater than 1. And instead of t dot size equal to 1 and t of 0 equal to 1, we could also say that if t is equal to the string of 1. In this way the answer is going to be no. Otherwise the answer is going to be yes. So this is how we can solve problem A. Is it clear now? If it is clear, please either use this emoji or write here in the chats, and if it is not clear, let me know to explain it again or in another way. Okay, awesome. So shall we move on to problem B? Yeah, for the last part I'm just saying that my number, first of all, the first two characters must be 1, 0, and then for the rest of them, for the rest of the string, for the rest of these, this must be a valid number. It shouldn't have any leading zeros and it should be at least 2. How can I check both of them? I just say that after checking that s.substr of 0 and 2 is not equal to 10, I call t, I set t as s.substr, substring of s starting from index 2 and its length is s.size minus 2. In s.substr you pass two parameters, the starting point and the size. So you define t like this, and there are only two conditions that it doesn't work. If t of 0 is 0, it means that we have leading zeros. or t is 0 itself. Anyway, it's bad. Or t was 1. In these two cases, the answer is no. Else the answer is yes. So that's all. Okay. Sure. So let's now move on to problem B. So I presume that it's okay. If you still have any doubts, let me know. So let's move on to problem B. Sitting in a bus. In this problem, we say that we have a bus consisting of rows of n seats numbered from 1 to n, and passengers come to this bus. Each passenger, all the seats are like a tape from 1 to n. Each passenger will sit in one of these seats, and each time they should sit on one of these seats that is adjacent to one of these adjacent seats to them is occupied before. Okay, so whenever a passenger comes in, it will sit in a free seat that has at least one occupied neighboring seat. So you have to say that you have the order of where these passengers sit, and you have to say if it is valid or not. Okay, I used a lot of words, seats and hard. So, okay, let me start talking about it. Well, in this problem, I can just say that at each time, an interval of seats are occupied. We have an interval of seats occupied. Because each time each passenger when comes in will sit either here, or has to sit either here or here, if he or she will sit next to one of the people who came before them. My drawing is not very good here. Okay, so each passenger will sit in one of these two seats, and so each time we must have an interval. We must have an occupied interval, because when we start from the first person sits in one of these seats, and then the next person comes and he will choose one of these two seats. So again, next time we have an interval. The next person comes and has to choose one of these two seats. Again, we have an interval. So you can see that as we go forward, it's like we are extending an interval, and they might form an interval. So how can we check if it is really like that? We can start from the first one. We can have a 4 starting from the first person and go to the end. Well, first of all, I say that I define L and R. I want L and R to be the interval that I'm considering. That interval that each time must be extended. I think there are two cases. Either I do not define them and I define everything on 4, or I start my 4 from 1 instead of 0. And first I set my L to be A of 0 and my R also to be A of 0. And then I can say that in here, the next person, AI, must be either L-1 or R+1. It is the only two ways that it is next to these seats, and this way it will extend, he or she will extend the interval. So I just say that if AI is equal to, for example, L-1, I will extend my L? I set L equal to L minus 1, or I can just say L minus minus. Else if AI was equal to R plus 1, I just say R plus plus, else the answer is no. So for example, I can define a boolean like bad that shows that if this array is bad or not, and bad is initially false, else I set bad equal to true, and at the end I can just see out if bad was true, I can say no, otherwise yes. And this is how you can solve problem B. Is it clear? So, for example, if I see for example, third example that we have 2, 3, 1, and 4, I can just see that initially, this is my seeds. These are my seeds. Initially, the first person comes and sits here. So this is my interval. Then the next person comes and sits here, so, at the third one. So my interval becomes this. Then the next person comes and it is equal to, so this one was equal to R plus 1. This is equal to L minus 1, so it will extend the leftwards. So it comes and sit here and extend the leftwards. The fourth person comes and it's equal to R plus 1, so it increases my R, extends my interval. And this way I can just say that if this was kept happening, I can just say that everything works. Otherwise, it does not work and they do not form interval. Okay. Does it make sense? Please, again, if it is okay, either use this emoji or write in the chats. And if it is not clear, let me know to discuss any part again. Okay, shall we move on to problem C then? Everybody are okay? Okay, sure. Because most of people want me to move on to problem C, maybe it's best if for now we move on to C. But maybe I'll put a link of this code in the descriptions. So let's move on to problem C. Numeric string templates. This problem states that you have an array and a string, and you have to see that if they have the same pattern or not. Having the same pattern means like this. If two numbers, AI and AJ, are equal, then SI and SJ must be equal as well. And if SI and SJ are equal, then AI and AJ must be equal as well. So you are given an integer n, which is the number of elements in A, and then you have m values, m strings that you will be given, and for each one of them you need to check if they have the same pattern, they have the same template with your array. And it is guaranteed that the sum of n across all test cases does not exceed 2 times 10 to the 5th, and also the sum of the strings do not exceed 2 times 10 to the 5th. So when you have this array, and this is your array A, and assume that this is your string. If for any string the time we spent, if in O of S, O of length of S, we can answer to this, then it's okay. We've solved the problem. If we can respond to it in O of the size of S, it is okay, because the sum of the size of S is not much, is at least 2 times 10 to the 5th. So what I can do in here is this. I can define two maps, one map from int to char, and let's call it m1, and another map from char to int, and name it m2. So map, as the name suggests, it just maps some object to another object. So it just maps, this first one, just maps any int like x to any character like c. This one, m2, maps any character like c to an integer like x. So map, as the name suggests, it just maps some objects to another object. So we just need to have a for, and we know that the size of s and size of a are the same. So we just need to have a for. Let's call that size as, let's do not call it anything. Let's just have the for to s dot size I plus plus. I have a process for matching a number and a character. So I have a process, I will complete this code, but let's first me tell you that I have a process for matching a character and an integer. The point is that, you know, the numbers and the characters must correspond to each other. They must be matched to each other. For example, in these inputs that you see, for example, in the first one that its answer is yes, a and 3 are matched. Wherever we have 3, we have a. Wherever we have a, we have 3. So a and 3 are matched. So we need to match a character like a to a number like 3. Or, for example, b in here is matched to 5. F is matched to 2. 1 is matched to this. So every number and every character, they are matched with another one of the other type. Every character is matched to one number, and every number is matched to one character. Every number that you see in here and every character that you see in here. So I must have a process for matching a character and a number. How does that process work? I can just say that when I want to match two of them, I must say that if my character is C and my number is X, I want to match C and X. It's like I want to marry them. You know, you can somehow look at it like that. I can say that M1 of C is equal to X, and the first one was into char, so M1 of X equal to C, because the first one maps an integer to a character. So M1 of X is an integer, is equal to C, so the match of X is equal to C, and the match of C is equal to X. But there is one more thing that I should take care of. When I match them, I need to make sure that they are not right now matched with another thing. They are not already married, you know? So I need to make sure that they are not already matched with another object. They are not, for example, an integer is not matched to another character, or a character is not matched with another integer. If that was true, then I do this. So first I do the process of matching them, and then I need to check that when I've done the matching, I just do the matching if they are not already matched. Maybe they are already matched either to each other or to another integers and characters. But first I do this process if they are not matched yet. I match them to each other. If they are matched, I do not change anything, and then starts the process of checking. So after that, I will just check if these two integers and characters that I'm seeing them with each other, are them really matched of each other or not. If they're not, this is bad, otherwise it is good. So I say that first of all, I have the process of matching them, then I have the process of checking it. So in here, I can just say that, first of all, I can say that if not M1 dot count of AI, this is just saying that if M of A1 is defined or not, if M of A1 is something or not. And let's, instead of M1, AI and CSI use what I have defined already, X and C. So X, my X is A sub I here, and also my character C is S sub I. So I can say that if already m1 dot count of x was 0, it means that m1 of x is not defined, so it's not matched with anything. So I need to match it with C. m1 of x is equal to C. Do not forget that this is the process of matchmaking. So I first do the matchmaking. First I make matchmaking, I do matchmaking, and then I do checking. And then I check if these two values that are seen with each other, are them really match of each other or not. So I first do matchmaking and then I do checking. So also the other side must be checked as the if not of m2 dot count of C, m2 of C is equal to x. And then I say, okay, this way I can just make them match. And now I know that X has some match, C has some match. Either it is defined before or it is defined now. Anyway, right now, after this part, they have matches. So I just need to check that if they are the match of each other. So in here, I can say that if m1 of X was not equal to C, or m2 of C was not equal to X, then it is bad. So I just say bad equal to true. And again at the end I say that if bad was true, the answer is no, otherwise the answer is yes. So this is all I'm doing. So I define maps. As I go forward, I make these values match with each other, and so first I do the process of matchmaking, and then after that I do the process of checking. They are individual. They are being done individually. Okay. This way it is cleaner. So, is it clear for you? If it is clear, please again use either this emoji or say in the chats. How to traverse on S as M is also there, and so no, the point is that that is a very good question. That is a very good question. So you are asking that what happens if we have a 4 of size S? Is that okay or not? You know, if you look at the statement, if you take a look at the statement, you know that the sum of the lengths of all the strings does not exceed 2 times 10 to the 5th. So even if for each string S, I have a 4, for each string S, I have a 4 of size O of S, in total, the sum of the sizes of these S's is not a lot. I do not care that I'm given a value M. Yes, that's right, I might have a lot of strings. I might have M strings, but I know that the sum of the sizes of these strings is low. So even if I do for each of these strings, I have a 4 of their size, the sum of these sizes is not too high. So I'm gonna be okay. Is it for sure? Is it sure? Okay, so if it is clear, please use again this emoji or write in the chat. If it is not, let me know if we should move on to problem D now or not. And I will discuss all the problems. All the problems will be discussed today. Thanks a lot, Ronnie. Okay, so I think now we can move on to problem. We can can now move on to problem D. Let me first bring it. Okay. So, right, left, wrong. This problem says that Vlad has found a strip of n cells. On each of these cells of this strip, either we have L or we have R, and we can choose, each time we can choose some L and R, such that S sub L, this lowercase l, S sub L is equal to L, character L, and S sub R is equal to character R, and then add the value of the sum from A sub L to A sub R to the current score and replace all of these values with dots. And at the end you want to maximize your score, and the value of n is up to 10 to the 5th and a's are up to 10 to the 5th, and the sum of the values of n's do not exceed 2 times 10 to the 5th. So we have this strip, and we know that we have this strip, and when each time we can choose one L and one R, the L must come before R, and add all of these values to our total sum, and at the end we want to maximize that total sum, that total score. As you can see, it is the best as soon as we have two LRs like this. We have L, L, R, R. You know, what I argue is that it's the best if each time, if you consider each of these cells, you can see that for each of AIs, it will be calculated. You can count that how many times this AI will be calculated in your total score. It will be calculated as the number of L's that you choose in the left side of it and the number of R's that you choose in the right side of it. So the number of intervals that their L is to the left of AI, to the left or equal to AI, and their R is to the right or equal to I. So, for example, if there are 3 intervals such that their L is to the left side of this point, this cell, and their R is to the right of this point, and it does not even matter that how are they matched with each other. They can be matched anyway. But if you just know that how many L's is chosen to the left of them and how many R's are chosen to the right of them, how many intervals such that both of these happen for them. How many intervals do you have such that their L is to the left of them and their R is to the right of them? If you can find that out, then you know that how many times A sub I is counted. So the point in here is gonna be to just find out that what is the maximum value for all A sub I's. First of all, I prefer to find out that in any suffix, how many R's do I have? First of all, I want to calculate that in any suffix, how many R's do I have? This helps me in order to know that if I have several open intervals, how many of them I can close. The point is that maybe I start an interval from some point. I need to make sure that I can close it at some point. So I need to know that after here, how many R's do I have? If I do not have enough R's to close this interval at some point, then there's nothing that I can do. There's no way that I can open this interval because I cannot close it later on. And also, if you consider a case like this, for example, I have L, 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 R, R. In here, I know that I only have 2 R's. So I can have at most 2 intervals. In other words, I can choose at most 2 L's. out of these 3 L's. So in this case, which 2 L's are the best to be chosen for my intervals? I know that out of these 3 L's, 2 of them must be chosen, not all 3. So which 2 L's do you think are the best to be chosen on this problem, on this case? Do you have any idea? So in this example, I have 3 L's and 2 R's. First 3 L's come and then 2 R's come. So I need to just choose 2 of these L's and match them with 2 R's. Which 2 are the best to be chosen? Exactly, the ones that are to the left, the extreme left ones, or the closest ones to the start. We have moved to problem D. So right now we're talking about problem D. And because most of people want problem D, maybe for now it's better if you do not do that. So, but if you really want that, maybe you can wait till the end of the stream and we can discuss it then. It is okay. If you want that, we can do that. So anyway, we have these cases and we know that when we can choose only 2 L's, it's the best to choose the extreme left ones. So this gives me the intuition of how to solve the problem. If I have limited number of R's and I need to choose that just some of these L's, it's always the best to choose some prefix of them as much as possible. So I want to start my L's from the left as much as possible. I mean as left as possible. So when I start from my left side, I can just do this. I can just keep track of how many open intervals I have. Whenever I reached an L, when I reached a new L, I can just see that how many R's are left in here. If the number of R's was greater than the current number of open intervals, it means that this L also can be chosen, because we have at least one free R. So I'm saying that if you consider you have several open intervals, so you have several L's chosen in here that they have started some interval but they are not closed yet. They must be closed, so they need to use these R's here. For example, if there are 3 L's that started some interval but they're not closed yet, they need to use these R's in future. So when this L comes, it has the least priority compared to previous L's. Because as I said, it's always the best to choose the leftmost L's. So this one has the least priority compared to the previous ones. So it can only be chosen if and only if these ones just put some R's left for it. If there is at least one other R left for this L, this one can also be chosen. Otherwise it cannot. So we greedily do this. I mean, each time we consider the first L, if we can match it with something, we will match it. Otherwise we just skip it. I mean, there's nothing we can do. So I know the number of open intervals. Whenever I reach some L, I see that if there was any R left, I just start another open interval from here. So I just say open interval plus plus, if there was some R left. If there was no open intervals left, I just do nothing for it. And also, whenever I reach some R, I know that one of these open intervals that I had previously, I can close one of them. So I can just say that open intervals, the value of open intervals will be subtracted by 1. Because I can close one of those open intervals. And this way, each time when I'm at some point, I know that how many open intervals do I have at this point. I know that how many intervals are open at that time. And as I said, the value that this cell will contribute to the final answer is going to be a sub I times this number of open intervals. The number of open intervals. Because in those open intervals, this cell will appear and it will be calculated. I mean, it will be calculated in that sum that will be added to our score. So I need to multiply a sub I by this number of open intervals. And this way I can update my answer. So I greedily start from left. Each time when I see some L, I see that do I have any R's left that can be matched with this L. If there's none, I just can do nothing. But if there is at least one R left, I just choose this one and increase the number of my open intervals by 1. Whenever I reached some R, if my open interval was greater than 0, it was not 0, I will decrease it by 1 because I can end one of those open intervals. And I can also see that what is AI times the number of open intervals. But there's just one more thing to say. I needed to also say this to you as well in here. So let me just tell you this now. There's also a possibility that we have, for example, 2 L's. Sorry for skipping this part. There's also a possibility that we choose 2 L's and then 3 R's. Again, in this example, like before, that we said that if we have several L's and all of them cannot be matched, it's better to choose the leftmost ones. In here also, it's the best to choose the rightmost R's as much as possible. So when I have a value R, I should also see that do I need to pick this R or not? Or in other words, I can just at the end just mark all the R's that are chosen, and I can say that I can just find out. So I can just say that at the end I can see that how many L's and how many R's I've chosen. So I do not do this at the beginning. I mean, I do not do this in my first 4. So I just do the first 4 to just see that how many open intervals I had. Whenever I see an L, I add 1 to my open intervals if there are enough R's. And whenever I see R, I close one of them. And at the end, I see that how many L's, and how many R's are chosen. How many L's and how many R's are chosen. For example, if there are X L's and X R's, definitely the number of L's and R's will be equal because we just made sure that they are being matched with each other. At the end, I can just say that, okay, if you've chosen X L's and X R's, those X L's that you chose must be the leftmost L's, the leftmost X L's, and those X R's that you've chosen must be the rightmost X R's. This way you know all of your L's and R's, and this way you can then run your second 4 to calculate the score, and this way you know that when an interval is opened and when an interval is closed, and then you can just see that how many open intervals you have at any point and update the answer accordingly. I know that it might have become a bit complicated, so let me see what is your situation right now. Did you understand what I was saying? Yes, I will explain one of the examples. Declare 2 pointers I and J from leftmost and rightmost. That also works. Yes, that is even better approach. Yes, this approach is even easier and better. I will explain this one as well. And I will do dry run on test case. Okay, so first I just do a recap on this solution, and then I also explain to you the 2-pointer solution as well. That might be a bit easier to understand. But let me first recap what I was saying in here. I was just saying that it's the best, if you have some L's, it's the best to choose them as the leftmost L's as possible, and R's must be chosen. If you are going to choose X R's, it's the best if you choose the rightmost X R's. So the point is that you can start from the beginning and you know that at any suffix how many R's do you have. This way you can find out all the L's that can be matched. Whenever you see an L and you see that what is the number of your open intervals, if there was at least one additional R to the right, you will choose this L as well. And this way you can see that how many L's could you match. So you see that how many intervals you can choose. For example, if this was X, when you found out how many intervals could be matched, and as I said, it's enough to do like this. Whenever you see an L, if there was enough R, you increase open interval by 1 and also increase X by 1, because here you've seen another interval, you've chosen another interval as well. And then when you see an R, you will decrease the number of open intervals by 1. And you go till the end, then you have X, and when you have X, you can just start running another 4 and choose the first XLs and the last XRs, and then see that what is the sum of them this way. So this is the approach that I was talking about, but there's also another approach using 2-pointer that you said, and this is even easier. The point in this one is that we do not try to find X. You know, the first fact that we said in this problem, you just need to first try to just completely comprehend this fact. Let's see that if you are okay with this fact or not. The fact is that if you are going to choose some L's and R's, let's say XLs and XRs, it is optimal to choose the leftmost. This is the main fact, this is the key fact that helps you to solve this problem. It is optimal to choose the leftmost XLs and the rightmost XRs. Okay, so if you are going to choose some L's and some R's, for example XLs and XRs, it's always most optimal to choose the leftmost L's and the leftmost R's. Are you completely okay with this part first? If you are okay with this part, please again use this emoji or say that in the chats. If any part of this fact is not clear, first let me know to explain these parts more than this. So the first fact is that if you are going to choose several L's and several R's, it's the best if you choose the leftmost L's and the probable statement is, okay, I will just do a recap on that one as well. It's the best to choose the leftmost L's and the leftmost R's as possible, because this way these intervals that we choose, their length will be maximized and they will include more characters. I mean, yes, you can choose another L as well. I mean, if you're gonna choose XLs and XRs, you can also choose, for example, an L here and do not choose an L here. But this is not optimal, because if you swap the situation of these two and instead remove this one and choose this one, these characters will also be included. So if you're gonna choose XLs and XRs, it's always the best to choose the leftmost XLs and the rightmost XRs. Okay, initially we have no dots, so dots will be made during the process. And just as a small recap, the problem just wants to each time choose an L and R that are not equal to dots and just sum up everything from L to R and turn all of those characters into dots so that you cannot choose them again. For example, first you choose these two and make them dots and add these values, and then you choose, for example, 1 and 2. And then make these dots. Again, in this example, you can see that 2 intervals are chosen, and in these 2 intervals, the 2 leftmost L's are chosen, and the 2 rightmost R's are chosen. if I was doing something else, for example, if I was choosing this L and this L and these two R's, I could just remove this L and instead in that interval use this one. This way these two elements were included as well. So if you're gonna choose XLs and XRs, it is always the best to choose the first XLs and the last XRs. So this is the main fact that you need to know on this problem. And when you know this, the rest of it would be a lot simpler. So now when you know this, it's always the best to choose the leftmost XLs and the rightmost XRs. We don't know X right now, so my previous approach was to first calculate X and then use that, but we can even not calculate X, just directly try to solve the problem. And for doing that, I can just do this. I can do a two-pointer. This approach also works. I can do a two-pointer. P1 can be here and P2 can be here. So initially P1 is equal to, let's say we use zero-based indexing. So P1 is 0, P2 is n minus 1, for example. And I can say that while P1 is less than P2, definitely P1 must be less than P2 if you want to have any hope to add another interval as well. I can say that while P1 was less than P2, there are several cases. First, I can say, so I know that my P1 is somewhere in here right now. Initially, they are at the two endpoints, but in the middle, they're just somewhere. They can be anywhere. So I'm considering the general case. P1 is, for example, here. P2 is here. If P1 is equal to R, P1 cannot be matched with anything because I'm just considering this part. I presume that I deleted everything other than this interval from P1 to P2. At the beginning, nothing is deleted, so my P1 is at the beginning, my P2 is at the end. But right now, I consider that my interval is from P1 to P2. If P1 is R, then because I only am considering this interval in here, it cannot be matched with anything. So I can just get rid of it. If P1 was equal to R, if S of P1 was equal to R, just say P1 plus plus, and let's just keep the sum of this interval as well. You will see that's why I will keep the sum of this interval. So let's have some sum that is initially the sum of all the numbers, In R4, I can add anything to my sum at the beginning. I just want to keep the sum as well. You will see that why it is helpful. So I delete it from my sum minus equal to A of P1 and P1 plus plus. I can also write it like this. Sum minus equal to A of P1 plus plus. So it's both removes this value from sum and also increases P1 by 1. And then I can say that also, with the same idea, if P2 is L, it is not useful as well, because it cannot be matched with anything. Because I'm only considering this interval. This interval is the only thing that is left from my array. So also I say that if S of P2 was equal to L, sum minus equal to A of P2 minus minus. Otherwise, the other case is if none of these two happens. The other case is if none of these two happens. And I forgot to also put else in here. If S of P1 is equal to R, I'm done. I just do nothing else. Else, if S of P2, if it was R, I just increase P1 for now by 1. I will just decrease P2 later on. Else, if S of P2 was equal to L, I just decrease P2. Else, it means that in here, I have L. In here, I have R. and they are the leftmost L and the rightmost R remained. So I can match them with each other. I can choose both of them. And I know that the order of matching L's and R's do not matter. So I can just pick this L and pick this R and choose this interval and add the total sum of this interval to my score. So I can say that else, let's match these two with each other. Else, I can say that let's add sum to my score. Score plus equal to sum, and then remove both P1 and move both P1 and P2 because now both of them are used and must be removed. Okay, so I say that sum minus equal to A of P1 plus plus and sum minus equal to A of P2 minus minus. Now you might ask that, but if we do this, if we match these two, everything in here will turn into dots and we cannot match anything else in the future. So everything will be ruined if we match these two. Well, the point is that we do not choose the ordering of matching them. We are choosing the set of L's and the set of R's that needs to be matched. We are not saying that really do this operation right now. I'm just saying that I must find the greatest prefix of L's and the greatest prefix of R's, and later on I will match them to each other. It doesn't mean that when I add this value to a score, it doesn't mean that I'm matching them right now. I will match them in the future. I just keep in mind that this L and R can be chosen, and then when they will be chosen, they will add sum to my score. Okay, so it doesn't mean that right now I will match them and everything will turn into dots and I cannot do any other operation. No, I just save that this L and this R can be matched. I will do that last, after everything in middle. I will do that at the last step. So I do not just after this just add do an operation on this L and R. I just keep in mind that this L and R can be matched to each other and add that sum to my score. Later on I will match them. Okay, is it clear now? If it is clear, please use this emoji or say it in the chats. Thank you. Is it clear? Okay, awesome. Awesome, nice guys. So this way I can just find what is the total sum of these values, these intervals. And do you want me to dry run a test on this problem, or should we move on to the next problem? And thank you guys for the emojis as well. These are very nice. Test case 4. Sure. Let me first see what is test case 4. Okay. Let's see test case 4. Test case 4 is like this. LR, LRR. Right? This is the fourth one. And this is 1, 2, 3, 4, 5. Well, in this one, I can just say that I want to try to find out the maximum number of L and R's that can be matched with each other. So first of all, my left pointer is here, my right pointer is here. I see that this is L and this is R, so they can be matched with each other. And 15 will be added to my final answer. Okay, let me show you this on tablets. So it is 1, 2, 3, 4, 5, and LR, LRR. So initially P1 is here, P2 is here. We see that this one is L, this one is R. So I'll move them both and add this value to sum. So my score will be added by 15 because my sum is right now 15. And P1 is 0, or because I'm in the explanation, let me use one-based indexing. P1 is 1, P2 is 5. I use one-based indexing in explanation so that you don't get confused. But in code, it's better if you use zero-based indexing. So my sum is 15, P1 is 1, P2 is 5. So score will be added by 15. Then these 2 pointers will move to here, and also they will be decreased from sum. So my sum will be decreased by 6, it will become 9. And P1 will become 2, P2 will become 4. And then in here we see that S of P1 is equal to R. So it cannot be matched with anything. So I just increase P1 and subtract that from my sum. So P1 will become 3 and sum will become 7. And then in here, now this is my P1, this is my P2. These are the place of my pointers. I see that for the left one, this one is L, this one is R, so I can match these two. So again, my score will be added by 7. And then P1 will become 4, P2 will become 3. So it means that, my while will not continue anymore. And my sum becomes also 0. So it means that I'm done with my while. And so my score will be at the end equal to 15 plus 7, which is gonna be equal to 22. Okay, so this way, for example, test case 4 works. Is it clear? We can do also with the stack, but it must be harder. Stack is used when you want to find out each of these characters will be matched with which of these characters. Thank you guys. So happy to hear that. Awesome. For problem C, no. The time complexity was the sum of the lengths of the strings, which was up to 10 to the 5th. So let's move on to problem E now. Let me first bring it. Okay, problem E, photo shoot for gorillas. It says that you have K gorillas and an N by M grid. You want to put these gorillas into the grid, and at the end, your score is gonna be for each of these gorillas have some height of AI. At the end, you can put every of these gorillas in exactly one of the cells, and each cell can contain at most one gorilla. Your score at the end will be that for every K by K square, you will sum up the heights of the gorillas, and for every K by K subsquare, you will add these values, and the sum of them will be your final score. You need to see that what is the maximum final score that you can have. So again, in this problem, I can look at it in another way. I can say that it is like, for every gorilla, I need to just know that any position that you consider in our grids, for any of these positions, in how many K by Ks this position comes. So for any of these positions, you need to know that if a gorilla will be here, how many K by Ks will cover this cell. For example, this K by K covers this cell. Also, for example, this K by K covers this cell. Also, for example, this K by K covers this cell. So there are so many K by Ks that might cover the same cell. So you need to know that how many K by Ks will cover this cell. And if the height of if you put a gorilla here with heights h, for example, the value that this gorilla will contribute to your final score, to your final sum, is going to be h times the number of these K by Ks that cover this cell, that cover this cell. So you need to multiply h by the number of k by k's that cover this cell. So this is another way that we can look at this problem. Do you all agree with this? I mean, this way, if we just make sure that if we just can find out that for every cell how many k by k's will cover this cell, we can just multiply them together and we can say that this is how much it contributes to your answer. If it is clear, so next I can just try to find out this value for every cell. So the point is that my value of n by m across all test cases does not exist 2 times 10 to the 5th. So I can have a 4 on all of my cells and try to find out, I can have a 4 on all of my cells and try to find out that how many k by k's covers this cell. And in order to find that out, you can just see that where the top left part of this k by k can be. I know that it's the distance of the top left corner to here must not be more than k. I mean, not in x-axis and not in y-axis. So I can find out the region that the top left part of that k by k can be in order to make sure that it will cover this one. Or I can also look at it like this. For the first cell, the number of k by k's that covers the first cell is 1. Because it's only one k by k that can be there. For the second one is 2. There are 2. For the third one is 3, and so on. And in here, in the first row, at some point it becomes k. And from that point it remains k. Because from that point, there will be one more k by k that covers that cell, but one of them will be removed. One of them, I mean, compared to the previous one was also in a k by k, that this one is not in that k by k anymore. So this is the numbers in the first row. For the second row, the point is that these numbers will be multiplied by 2. Because the first one, also they start in the y-axis, they start on x-axis, can be both here or here. So it will be 2, it will be 4, it will be 3, it will move on to 2k, and then it remains 2k. And the same happens if you start from bottom. And so there is going to be a region that it is going to be k squared. Exactly, there is going to be a region in the middle that it's going to be, all the cells in here are going to be covered by k squared k by k's. And the rest of them will gradually decrease from this value, from that maximum. So the point is that, I mean, the best way to find that out is to just, when you have a 4 on all your cells, you have a 4 I from 0 to n minus 1, and 4 j from 0 to n minus 1. So you have some lower bound and upper bound for your x and y. So what is your lower bound for x? I show it for L, B, X. It says that when I want to find out x and y of the top left of this k by k that covers this one, I want to see that what is the lower bound of that x. The lower bound of that x is gonna be maximum of 0 and I minus k plus 1. Because both, it must not be before 0 and it cannot be I minus k or before. Because if it is I minus k or before, it will not cover this one. Also, the upper bound, I show it with ub of x, is gonna be minimum of I and n minus k. It cannot start after I, and it cannot start after n minus k as well, because if it starts after n minus k, it will go outside of my rectangle. So that is not valid. So this way I can find out lower bound and upper bound for x, and in the same way I can find out lower bound and upper bound for y. Lower bound of y is gonna be again maximum of 0, and this time j minus k plus 1. upper bound of y is gonna be minimum of j and m minus k. Again, because if it is after m minus k, it will go, this k by k will go outside of rectangle. So for the x and y of the top left corner of that k by k rectangle, I have lower bound and upper bound. So I can say that the number of internum, which is the number of k by k's that will cover this cell, is gonna be equal to ubx, upper bound of x, minus lbx, lower bound of x, plus 1 times upper bound of y, uby, minus lower bound of y, lby, plus 1. This way I can easily find out that how many k by k's covers this one, and I can store all of these 9s in a vector. Is it clear so far? So far, if it is clear, please show it with the emojis or in the chat. If it is okay, then we will move on to the next word. Please again use the emoji, or it is not clear? Okay, sure. So I'm just saying that when we have these cells, I want to find out that for any of these cells, how many k by k's will cover, how many k by k's will cover this cell. It is important. Why? Because if I know that how many k by k's cover this cell, I know that the height of a gorilla that I put in here will be calculated in all of those k by k's. So the point is that I need to know that for any k by k, how many, I need to know for any k by k that how many, for any cell, how many k by k's covers this one, so that I know that in all of those k by k's, the height of this gorilla that I put here will be calculated. So I can add that I can add the height of the gorilla times the number of k by k's that covers that cell to my final answer. And the point is that if you consider a cell, the lower bound and the upper bound of the top left cell of a k by k that covers this cell, I'm saying that let's consider all the cells, all the k by k's that covers this cell. I'm talking about the top left part of them. What can I say about the top left part of them? First of all, the distance of this top left to this cell must not be more than k. So if it is some x and y, I want to see that for each k by k, let's consider that its top left cell is x and y. And this cell is cell I and j. I want to see that what are the conditions for x and y, so that a k by k that starts from there can cover this cell. Because if I know that how many of those x and y's exist, I can multiply that by the height of the gorilla that I put here, and I know, because I know that that gorilla will be calculated in all those k by k's. So I try to find out some lower bounds and some upper bounds for x. What is the lower bound for x? Well, first of all, x cannot start from before 0. So it should start from at least the first row. So it should not start from 0. And also, it must not be I minus k or less than that. Because if it is I minus k or less than that, it cannot cover cell I and j. So it is at least I minus k plus 1. So it is at least maximum of 0 and I minus k plus 1. Is it clear so far? Okay. Yes, that's exactly the same thing that we want to do. We want to sort them and calculate at the end. So I have this lower bound And also about the upper bound, I can say that my upper bound is going to be minimum of, first of all, I say that no x can start from after n minus k. Because if it will start from after n minus k, it will go outside of my grid. Because its height is k, if it starts from n minus k plus 1, its height is k, so it needs to also cover row number n. But we have no row number n. Our rows are numbered from 0 to n minus 1. If I start from row n minus k plus 1, my last row will be row number n, but there's no row number n. My rows are from 0 to n minus 1. So I cannot start from here. So first of all, I need to say minimum of n minus k, and also it should not start after I itself, because if it starts after I itself, it will not cover I. So this is the lower bound and upper bound that I have for x. The same thing is for y. For y also I have a lower bound, and this lower bound is maximum of, again, 0, it cannot be less than 0, and also it cannot be less than j minus k plus 1. Otherwise it does not cover this column. And also the upper bound for y. For the upper bound, I need to say that it is going to be minimum of m minus k, because if it starts after m minus k, it will go out. It will go out of the grid. And j, it cannot start after j, because if it starts, it will not cover this cell. So I have these lower bounds and upper bounds, so I need to say that the number of k by k's that will cover this cell is going to be upper bound of x minus lower bound of x plus 1, because I have these many choices for x, times upper bound of y minus lower bound of y plus 1. So this is going to be the number of k by k's that will cover this cell. Is it clear now? Why are we multiplying? Because, for example, assume that the height of a gorilla is 5, and it is in, for example, 6 k by k's. For any of these 6 k by k's, I need to add 5. So I have 6 5s. For any of these 6 k by k's, I need to add 5. So in total, how much does this gorilla contribute to my answer? 5. How many 5s? 6 5s. So it will be 6 times 5. Yes, you're right. For the first row, yes. This pattern is wrong. Yeah, I did a mistake. You're right. In here, the correct pattern is this. But it doesn't matter. I mean, we do not use this pattern. We just calculate it for everything. So in both parts, it starts from 1 to k minus 1. So, but this formula gives exactly those values. Awesome. Nice. Yes. So now we know that how many k by k's will cover this cell, and we can say that now let's have a vector and just push back. Let's have a vector and just push back that for any of cells, what is the weight of the cell? Let's call that the weight of a cell. The weight of a cell, like W of I and J, means that how many k by k's will cover that cell. Why I call it weight? Because any gorilla with height h, if it comes here, it will be multiplied by, its height will be multiplied by this weight, and it will be added to the score. So I can say that I can look at it like a weight. As your weight is more, it is better for you. I mean, the cells with greater heights, with greater weights are more valuable, because if we put a gorilla there, it will be multiplied by a greater value. And it's the best if we put our best gorillas, our tallest gorillas, in the heaviest cells, because this way I can multiply them. I mean, I can use those tall gorillas as much as possible this way. They will multiply by the greatest values. So it's better if I have a heavy cell and the tall gorilla, I put that tall gorilla in a heavy cell. So as much as I can, I give I give more coefficient to that tall gorilla. So I can just source all the cells. I know that the number of cells is n by m, which is up to 2 times 10 to the 5th. So I can just have a vector of this size and just store all the weights, and then source this vector from the greatest weight to the lowest weight. And I can also sort the gorillas from the greatest height to the lowest height. And I can then have a 4 on all the gorillas, and each time I match the gorilla number I with the cell number I. So at the end I have a 4 I from 0 to k I plus plus. At the end I say that ans plus equal to vec of I, which is the weight of cell number I if we source all the cells from the greatest, from the heaviest one to the from the heaviest one, times if we sort all the gorillas from the tallest one, it will be vec of I times, let's say, a of I, or h of I. Let's call it h of I as the height of that gorilla. And then at the end, this is gonna be my final answer. Is it clear? This was question E. This was problem E. If it is clear, I don't know what can I do about cheaters. But I can pray. That's the most maybe I can. Okay, awesome. I don't know about the cheaters. Maybe we can do something in future. Not sure what we can do. And the cheaters, guys, are not only in contests. There are also cheaters in, I don't know, it's nice to say that or not, but there's also cheaters in upvoting, downvoting. I don't want to accuse anyone. I mean, whether maybe some people are rivals or something. I don't know that. And maybe some people maybe at all do not like my live streams and so on, and maybe that's why they do not want. But I sometimes see that in the blog posts that I have. For example, like in this one for the last contest, there is a period of time, for example 1 hour, 2 hours, that a lot of downvotes will be sent to my blog posts, and it's not normal. For example, it is a positive number, but for example in an hour or an hour and a half, a lot of downvotes will be added to my contribution, which looks like it is fake accounts. But I don't want to really accuse anyone, and I know that maybe some people really don't like the live streams, and that's completely okay. But it's kind of weird. So the issue of fake accounts is really serious. That really happens, and it's both in the contests, and I don't know, maybe Codeforces can do something about IPs. When people enter Codeforces with the same IP, maybe Codeforces can block them. For example, if 10 accounts are with the same IP, they can block them. Also, yes, the famous ones, the ones that are leaked, who cheat in the contests, they can also be blocked from Codeforces. They can be banned. Maybe if I have a chance, I will talk to the officials of Codeforces that if they can do something about it. I hope it gets better, especially with AI, with the growth of AI. I think it will be simpler to find out cheaters. I think there are some tools that they can choose in very soon. Maybe in less than a year, there are gonna be a lot of tools that they can choose. But guys, do not care a lot about just CF rating. I mean, if you are good enough, I mean, the number of cheaters is not that much that has a lot of effects on your rating. It has effect for sure, because there are some people that they are cheating, and because of cheating their rank is greater than you, and they will have some, but it's not that much. I mean, if you see the ratio of all the people that participate and the cheaters, it is possible to ignore them and just try to be the best as best as possible. I mean, the cheaters effect is like maybe 5 additional rating. 5, you know, I mean, if your rating had to increase by, for example, 20, now it will be increased by 15, for example. If it had to be decreased by 10, now it will be decreased by 15. So it has effects, but try to focus on the best you can do, and it's okay. And over time the cheaters will be better, the situation cheaters, but for now just focus on learning, because at the end you either want to participate in some competitions, or you want to do some coding interview, or you want to do something that this knowledge that you have is important. So just focus on that. That is gonna be better, I think, if you focus on this. Okay. Thank you guys. Thanks a lot for your support. I didn't say this that anyone wants to offer. I mean, I don't want to even care about that thing. I just wanted to say that, yeah, this sometimes happens, and that's okay. And I mean, it's important that we learn to do our work regardless of all these things. I know that there are some people who have fake accounts and try to disrupt something, and you guys also know that there are some people who try to disrupt your work with the things that they do, which is not correct really. But the point is that if we learn to do our work regardless of people who do something, and the point is that these people cannot really have any serious effect on us. The point is that if we do not get distracted and we just focus on our own work and try to do that in the best way possible, I do not believe that these people who do some cheating or something not really ethically correct, they cannot do anything important to you. It's just important if you focus on what you do. That was the main thing. So yes, that's the point. That's the point, that if you need to just don't care about some people, and that's the same thing that I'm telling you. And it's okay if you just train enough, even with that situation, you can increase your rating. That's okay, that happens. Okay. And guys, if you want to support my work, I would appreciate it if you can like the video or subscribe to my channel. That could also really help. Yes, and I will discuss problem F and G. Shall we move on? And H. Shall we move on to F? 3 problems are left. Thanks a lot, guys. Thanks. So let's move on. Thank you. Thanks a lot. And you know, the point that there are so many people who support my work and really like my work, and they're learning from it, and they're getting some benefit about it. I mean, the ratio of people who do wrong things is so low compared to people who are supporting or etc. So also, when I see it, I see that when the ratio is so low, it's possible to ignore that. Also, that's the same in the contest. Yeah, maybe 1,000 people will cheat, but how many people are competing? I mean, maybe 20,000 people are competing. So there are 19,000 people who are not cheating, and they're really competing. And I think maybe just do the best you can do, and hope that it will not have an effect. In problem C, no, it is not n times m solution. It's our solution. In problem E, our solution is O of size of S. The sum of the O of size of S, which is at most 2 times 10 to the 5th. So let's move on to problem F. We have 3 problems left and not a lot of time left. So let's say let's talk about problem F. It says that you have n rectangles, the ith of which has a width of a sub I and the height of b sub I. You can perform the following operation an unlimited number of times. Choose a rectangle and a cell in it and then color it. Each time you completely color any row and column, you earn 1 point. Your task is to score at least k points with as few operations as possible. Suppose you have a rectangle, for example, with width 6 and height of 3. If you want to score 4 points, you can do it by 12 operations, for example, because the height is 3. So, and an important thing in this problem is the constraints that we have. N is up to 1,000. The number of rectangles is in 1,000, and k is up to 100. So you have at most n rectangles, and the number of points that you want to get, your score that you want, is gonna be at most 100. And each one of them, ai and bi's, are up to 100 as well. So first of all, I want to do this. I want to find out for every rectangle, I want to find out that how many points I can receive for every rectangle. I want to find out that how many points I can receive if how much I need to spend if I want to receive x points. I can pre-process that and save that. So for rectangle number I, let's say I save that, or I say that cost of I and x means that what is the minimum cost, what is the mean cost to get x points from rectangle number I. So I can find that out because how many i's do I have? It is at most n, and I know that n is at most 1,000 over all test cases. So for each one of them I have 1,000, and k is up to 100 as well. So for each rectangle I can just fix that how many of these points I will get from the rows, how many of these points I will get, let's call it for example r, how many of them I will get from columns, let's call it for example c. So if there are r rows that I will complete and c columns that I will complete, I need to say that how much I should spend. The value that I spend is gonna be r times n plus c times m, because I need to color all these cells. But the point is there are r c cells in here that I'm counting twice. There are some cells in here that I'm counting twice, and I can just calculate them once. So I need to subtract by r times c, right? So my value will be equal to this, r times n plus c times m minus r times c. And I can say that cost of I and the score that I'm getting is r plus c. So cost of r plus c mean equal to this value. So this way I can update the cost that each rectangle individually will have to get some points. I can just have a 4 on I can have a 4 on r and c. I has, it takes 1,000 iterations at most. R and c are both up to 100. So it's gonna be good. It's gonna be okay. So this way I can calculate all the costs. That if I only have this rectangle, what is the cost to color it? Is it clear so far? So again, if it is clear, please use the emojis or say that in the chat. So I'm saying that for every one of the rows, for every one of the characters, and for every number of the rows and every number of the columns, I can just find out that what is the score. Can I make a detailed video about that? Yes, I will. In the live streams, I will cover those things. Right now we're on DP, and then we will move on to other topics, and we also will have sessions on specific difficulties, etc. Every week, Fridays from 12 to 14 GMT, we're gonna have a topic stream. So anyway, this is how we can find out the costs for individual rectangles. And now I want to combine these rectangles. So I know that I have n rectangles, and I can choose from any one of them. I can make a row or a column 1 in any of them. So I can just say that, and I know that the number of rectangles themselves is up to 1,000. So I can have now dp of I and j, that this one, right now I says that if I use, what is the, let's say again, dp of I and x, so that it is what gonna be more similar to here, that we define cost of I and x. This times, I'm saying that what is the mean cost to score x. This time, instead of just using rectangle number I, we use all the rectangles from 1 to I. From 1 to rectangle number 1 to rectangle number I. So this is my DP now. Instead of just using rectangle number I, now my definition is that what if I use rectangle number 1 to rectangle number I? And if I do that, I can say for every when I add another rectangle, I can again have a for that how many of that score I get from here, how many I get from here. For example, again, A of this score will be taken from this rectangle, and the other B of them, where B is equal to x minus A, will be chosen from here. I get it from here. So my DP, my new DP of, if I define a DP prime, that is going to be my DP, or no, not DP prime, just DP of I says that I'm at rectangle I. And if I fix this A and B, I can say that DP of I and A plus B, which is equal to x, which is equal to that x that I was talking about, is going to be mean equal to is not really a C++ operator, I just use it for explanation, is mean equal to dp of I minus 1 and B, because I said that I will choose B from the previous ones, plus cost of I and A, which I have already calculated. Cost of I and A says that what is the cost if from rectangle number I will choose a from rectangle number I get A points. So this way I can update my DPs, and at the end my final answer is gonna be DP of N and K. If I use all the N, rectangles, and I want to have K as my final score. Yes, you can have lectures on mathematics in future. Yes, sure. So is it possible? Is it clear? My mind blew up. Yes, the DP equation is this. DP of I and A plus B. You know, the definition, first let me recap the definition of the DP. DP of I and X means that what is the minimum cost to score X if we only use all the rectangles from rectangle number 1 to rectangle number I. And then I say that I already know that what is the minimum cost to score X if I only use rectangle number I. This is only using rectangle number I. But in here, I'm saying that in here, I will use all the rectangles from rectangle number 1 to rectangle number I. So it's not just one rectangle. It's all the rectangles from rectangle number 1 to rectangle number I. And I say that in this case I can define DP of I and A. I can just say that how many scores that I will get from this last rectangle, from rectangle number I. So I have a 4 on A and B. I score A from this last rectangle and B from the rest of the rectangles from before. So my total score is going to be A plus B. So my dp of I and A plus B will be mean equal to dp of I minus 1 and B if from the first I minus 1 rectangles I get B, and from the last rectangle what is the cost if I want to score A. And this way I can calculate the final answer. It's possible. Nice. Is it clear or is it possible? If it is clear and we can move on to problem G, again please use this emoji or write in the chats. Otherwise let me know to explain it any parts again. Awesome, nice. So yeah, maybe. Yeah, you're welcome. Yeah, you can see any part of the video even while the live stream is going on. You can see any part of it as you want. So, and after the live stream also, you can just see the whole video. So let's move on to problem G. Call during the journey. It says that you live in a city consisting of n intersections and m streets, and there are buses between each two cities, and it takes, if we want to go from city number ui to city number v sub I, it takes L sub I sub 1 minutes to go there with a bus. But if you walk, it takes L sub I and 2 to get there if you walk along. And you have a phone call that you need to do it in all the minutes from T1 to T2, and also you need to be at your destination at time T0, at most at time T0. And while you're doing your phone call, while you're talking with phone, you must not be in the bus. You should walk when you're doing your phone call. You need to say that what is the latest time that you can start from your first city, from your source, in a way that you can get to your destination at the desired time, at most time T0. And the value of n is up to 10 to the 5th, m is also up to 10 to the 5th, and the rest of them are up to 10 to the 9th. In here, I want to use a variation of Dijkstra in this problem. I can say that, let's say for every vertex, let's define some sort of dp. dp of v says that dp of v, or in order to make the name a bit more clear, let's call this latest of v. Latest of v says that what is the latest time that I can start, that I can start from V. What is the latest time that I can start from V? And I can be at the last vertex at time T0. So it's like DP. As I talked about this in the live streams, when you have DP, instead of just solving a problem, you will define several sub-problems and solve all of them, and they will help each other. This is somehow like DP. Instead of just trying to solve this question for the source, I will try to solve it for all the vertices. So this is the definition of latest of V. At the end, the answer is going to be latest of 0. The latest time that I can start from 0. So what is my base case in here? From where I can start? So what is my, what do you think is my base case? Let me write something. Well, our base case can be for the last vertex, for our destination. We know that we need to be there, but by time t0. So the latest of, if we want to go from vertex 0 to vertex n minus 1, the latest of n minus 1 is going to be t0, t sub 0, right? So this is our base case. The latest of n minus 1, you missed the light, so I need to change this color. Okay. So the latest of n minus 1 is gonna be t0. And for the, is it clear so far? I mean, are you following along? Please use this emoji again if you're okay with that. So the latest of n minus 1 is equal to t0. And for the rest of the vertices, I can say that I can do something similar to Dijkstra. Each time, just pick a set. Each time from your set, pick the maximum elements. Pick the one that its latest is maximum. And you can initially this time set the latest of all the other vertices, like I, as for example, minus inf, for example. So latest of n minus 1 is t0. Let's not use. The latest of n minus 1 is t0. The latest of all the other vertices is minus inf. Each time from your set, pick the one with the maximum value of latest, and let's update all the vertices that have an edge to this. I can say that for each one of them, it's better if I use bus, because this way the latest of those vertices can be as late as possible. It's gonna be for any of them. I have two ways. I show them with W1 and W2. W1 is if we use bus is W2, W sub 2 is if we walk. So when I want to update a vertex, I can just say, I know that what is the latest time of this vertex. And I know that if I can use a bus or not, because I know that if I will use a bus here, if I come from here to here, I know that this way, how long does it take to come there, and what is the time interval that I will be in bus if I use the bus between these two cells. I know that how long I'm in the bus and what is the time interval in the bus if I use this bus between these two. So I know that if that intersects with the interval that I need to talk with phone, or it is not. If it intersects, I cannot use a bus. So there are two possibilities. So if I can use a bus, it's easy. So if this is vertex V, this is vertex U, that way latest of U, similar to Dijkstra, can be updated by can max equal to latest of V minus W1. And maybe I need to insert it back again to the set. Erase it from the set before this, and after that insert it back again. Or if in that time period, I'm gonna, if in that period that intersects with the time that I need to talk to phone, I need to walk. Either I have to walk or I need to start sooner from here. So I can consider, the idea in here is to consider these two cases. Either if you want to talk, it will be updated from latest of V minus W2. Or if you want to use a bus to come here and before you need to do your phone call. So you do it in a way that you will be here at time t1. You will be here at time t1. And from here you need to start from t1 minus w1. So it's the case that you will start a bit sooner from this cell so that you can start talking with phone there. So you need to be here at time t1. So you need to start from here at from t1 minus w1. So you need to see that which one of these two is better and which one of these two is maximum and choose that one. Either you need to walk in here or you need to just start later in this cell and so that you can use a bus. And this way at the end all of the latest of all the vertices will be calculated very similar to Dijkstra. The only difference is that this time each time we pick the maximum out and update everything else. And everything will be maximized with the other values. Initially they are minus inf, and there will be minus inf means that they're not calculated, and each time they will be maximized. And this way I can find out the answer. If it is okay, we can move on to problem H, because it's a bit late, we need to do it faster. Is it clear? Shall we move on to problem H as well? If there's any serious issue, let me know. Otherwise, we can start talking about problem H2. Okay, awesome, nice. So let's talk about problem H as well. Okay, problem H. It says that you have some numbers. You have a set of numbers. Each time you can insert a new element x into the set, or remove element x from the sets, or report the k-load of the set. And the k-load is defined to be the minimum positive integer d, such that the integers d plus 1, d plus 2 to d plus k minus 1, those k consecutive integers are not in your sets. Each time after each operation, you need to say that what is the k-load of your sets. Okay, sure. See you tomorrow. The recording version of me sees you tomorrow. Okay, so I can say that in here I can just pick. I can really have a set. I can have a set of ints of st. I don't know why this does not work, unfortunately. Let me. Okay. So I can have a set that in which I really will store all the values of my sets. So I have a set that is just my normal set. It stores all the values. And whenever I insert a value, the point is that I need to consider the blocks of the numbers that I don't have. For example, let's say as an example that my numbers are like this. For example, there is 2 here, 3 here, 7, 11, 14. I need to consider these blocks. For example, there's a block starting from 1 and ends at 1 here. These are the blocks of numbers that I do not have. This is a block in here that starts from 4 and ends at 6. There's a block in here that starts at 8 and ends at 10. There's a block here that starts at 12, ends at 13. And there's a block here that starts from 15 and ends at maximum integer. I mean, ends at inf. I can set inf as an integer that is greater than any other number, and that it's going to be greater than any other number. And I can choose my last number as that one. Because all my numbers, as you can see in here, all my numbers are up to 2 times 10 to the 6. And also because I want to have my k load, and k is up to 2 times 10 to the 6, if you even choose your inf as 10 to the power of 7, it's enough, because the last block for sure will have at least k numbers. So by choosing a finite inf, it would work. Now the point is that if you just picked all these numbers, all these blocks, the point is that how do you update these blocks? When you remove a number, for example, assume that you remove this 11, you need to just consider the first element before it and the first number after it. It is 7 in here and it is 14 in here. By removing 11, so you only consider the number before 11 and the number after 11. There are 2 blocks that will be removed, and instead of them, one merged bigger block will be added. So when 11 is here, let's use variables. It makes our work a bit easier. So let's say that this number is called x, this number is called L, this number is called R. You need to remove L plus 1 to x minus 1 from your blocks. So it's like you have another set of PII of all your blocks. So from your blocks, you need to remove L plus 1 to X minus 1. And you need to also remove X plus 1 to R minus 1. And after that, add L plus 1 to R minus 1 to your blocks. This way you can update your sets. And also, when you add something, it's vice versa. Again, you use lower bound and upper bound to find that when you're adding X, what are L and R's that you have. So in here, you remove these two and added these two, inserted these two. This time you do vice versa. So this time, you will first remove L plus 1 to R minus 1. You will remove this, and instead you will add L plus 1 to X minus 1 and add X plus 1 to R minus 1 in this case. So this way you can keep all of your blocks. And now the point is that alongside these blocks, you can also keep good blocks. So you can define another variable named as good blocks, in which you keep all the good blocks you have. But what do I mean by the good blocks? The blocks that their sizes is greater than or equal to k. How can you find out? You know, the point is that each time you are either erasing a block or inserting a block. Let's make these erase blocks. Erase block and insert block two functions. So you have a function that takes a p. Instead of just saying that blocks dot erase something, let's just make them some function. So void of erase block that gets some p. You just need to say that if the size was greater than or equal to k, if the size was greater than or equal to k, I'm using pseudocode in here, you need to also remove it from the good blocks. From the good blocks, and then remove it from the blocks. Remove from blocks, from the blocks. And also you can have a void of insert block that is the same. It takes a pii of p. You just need to see if the size, or p dot second minus p dot first plus 1, for example. If size was greater than or equal to k, you will just also insert it into good blocks. Otherwise, any way you add it to your blocks. And this way you can update anything. At the end, you just need to have the smallest block in your good blocks. And do not forget that always the latest block is in your good blocks, because your latest block is always long enough to be in your good blocks. You need to consider the smallest good block and just report the first number of it, the start of it, because that's the first number that is in the beginning of the block of size k. That's none of them are in your sets. So this is how you can solve this problem. Is this one also clear? What is better, up solving or rating wise practice? I think it's the best if you solve one problem or two problems at most that you did not solve in the contest, but do not do it too much. For example, do not try to solve all of the problems in the contest, because they might be hard for you. And if you want to solve problems that are very hard for you, it is not very efficient. You need to spend a lot of time, and you know the point is that you need to train wisely. You need to train efficiently. If a problem is too easy for you, you will end up solving that problem, but nothing adds to you. If a problem is too hard for you, yes, it can add a lot to you, but how much you need to spend time to accept that? Maybe with that time you could do better things. So the cost of that is a lot. Yes, you earn a lot if you can solve it, but the cost of it is a lot, because you need to spend, for example, 10 hours to solve a problem that is very hard, and in 10 hours you could do better things. So the point is that try to solve problems around your rating. From every contest, maybe the first problem that you haven't solved in the contest is a good problem to be solved. It's great to be solved. And it's highly recommended that the first problem that you have not solved, and maybe in some cases the first two problems that you did not solve in the contest, try to solve them. and accept them. But the rest of them, most of times, it's not good if you spend time on them because it's not the most efficient thing that you can do. Instead, you can try to solve more problems on CF around your rating, or maybe watch some videos, watch like some live streams, or watch some find some list of problems on some topic, for example on segment tree, on I don't know, dynamic programming, on number theory, anything, and solve them. There are better things that you need to do. So try to study efficiently, and do not do something. I mean, if you do so easy problem, it has no effect on you. If you do so hard problems, it has effect on you, but it takes a lot of time and it's not very efficient. But you need to find around your own rating and solve problems around that part. Okay, is it clear? Yes, exactly. How are we going to find L and R number in our set for given x to inserts? Yes, for your given x to insert, it's just some lower bound and upper bounds. I mean, you have your set st, is just using methods like lower bounds, st.lower bound and st.upper bound. You can find the first number. Lower bounds finds the first number that is greater than or equal to something. Upper bound is the first number that is greater than something. You can find the first thing that is, for example, greater than or equal to x, or greater than x, no matter, it doesn't matter. Call that R, and then that is that's an iterator on sets. You can say its minus minus, so call that an iterator its, and for example its R, and define its L as its R, and then say its L minus minus. So it's very simple working with sets. Maybe let me send you a documentation for lower bound and upper bound that you can use. Just take a look at these two links, and this helps you to work with lower bound and upper bound. If you want more information, you can check out these links. Yes, exactly. If the point is that you can solve hard problems by spending a lot of time. For example, you can spend 10 hours to solve a very hard problem, and it is helpful. But is this the most helpful thing that you could do in 10 hours? Would that be more helpful if in your 10 hours you were solving 7 problems of difficulty around your own rating? I believe that solving those 7 problems that are not also so easy, I mean each one of them took around an hour, maybe more than an hour. I believe that those 7 problems have a lot more effects on you than that one problem that you spent 10 hours. So it's important to do the training around your current states, around your current level. Don't go too high or too low. Do not believe that if you solve harder problems, it's better for you and you grow faster. No, you might stuck if you do that. That's not the most efficient thing to do. So, okay, doesn't this approach only work for fixed K? K varies around queries. I see. Let me take a look at it. Let me just take a look. I think you're right. So you're right. I presumed that K is fixed. I wasn't considering that K is not fixed. Let me take a look. Let me take a look on what people did. You're right. Thank you very much for mentioning that. Let me fix this. Okay. You're completely right. Yes. You're completely right. What I said was for fixed k, I need to just add one more thing to it, and that's this. When we have these blocks, we cannot have these good blocks. That was right, because k is not fixed. What we can do instead is that when we have these blocks, do you agree that the only values that matter are the first numbers of these blocks? I mean, if you're gonna choose one of these numbers, you're gonna choose the first number. The rest of them do not matter, right? If you're gonna choose a number, you will choose the first number of a block. The rest of them, because their block is smaller if it starts from there, and also they are greater numbers, so they are worse in the both cases. So I will not choose them. So I will have several pairs that this is a number and this is the block that it gives you. The point is that you can also have a segment tree. You can have a segment tree, and in the segment tree, just store that in this cell, save the size of this block. For example, the size of this one is L1, the size of this block is L2, the size of this block is L3, and so on. So the point is that you can just store the size of the size of those blocks in these cells, and then in your query you need to find the smallest value such that the size of its block is greater than or equal to k, where you can do a binary search on segments. How does that work? In each node of segment you can store what is the maximum value in its subtree, and each time you can see the left child. If in the left child you have a value greater than or equal to x, you will go to the left child. If not, you will go to the right child. So this way you can just solve the problem. You're completely right. K is not fixed, and we need to also add this part to the solution. I mean, it makes it a bit harder, but it is still solvable, because we can just store in a segment tree that at each point what options do we have, and we need to find out the first option that we have with value greater than or equal to k, and we can easily use a segment tree. And since our numbers are also up to 2 times 10 to the 6th, this would work. Is it clear now? Is the issue resolved now? Yeah, sorry for that. At the beginning, when I read the problems, when I read the problem, I assumed that k is fixed, but you were right. It is not fixed. I hope that it is resolved. If it is okay now, please use this emoji or say that in the chats. How many problems? Yeah, awesome. How many problems you used to do when you were trying? Problems a little higher than your rating in a day. Well, I think like solving 5 or 6 problems a day is great. A lot, but if you want to do it on a regular basis and you want to just keep some threshold, at least I think 2 or 3 problems would be nice as well. Maybe if you solve problems from your own rating or a little bit higher than that. How is College Park for masters? I'm not sure about it. I don't know about the programs for masters, but you can apply. I think you can visit the web. I think you mean the University of Maryland, because the only well-known university in here is University of Maryland. You can search for it, and there are the programs you can apply for them, I think. Okay, we will talk about it in future. If you want to come to the US, I think I'm not sure about if it is the same for all the countries, but as far as I know, for F1 students, for students who want to study here, I mean for the students, I think in the US it's easier if you just do PhD than master. I think it's harder to enter it for master, but you can see. Yes, that's nice. 2 or 3 is great. 2 or 3 rating 200 higher than your rating is great. I mean, just keep doing that. That would be great. Even I believe that even your own rating is also good, because the point is that when you're rating as something, it doesn't mean that you can solve all the problems with that rating. There are a lot of problems that are really easy for you rating wise, but the point is that they're not in your style. For example, you're okay with, for example, DP, but you're not okay with data structures, for example, or not easy for okay with number series. So the point is that even when you do it, the problems with your own rating, it doesn't mean that you already know them. It's not like that, because there are several important different topics, and there is definitely a lot of problems from your own rating that you cannot do good on them, and a lot that you can easily solve them. So the point is that you're not the same on all the problems with the same difficulty. So I believe even your own rating is not a bad thing to, it's not like your rating is already this, so you're okay with this. Your level is not one-dimensional really. It has so many dimensions, and in so many styles of problems you might not good at your own rating. So you need to work on them. This way you can work on your weaknesses. So it would work. So yeah, I think that solving a lot of problems will help you a lot. Try to solve problems from Codeforces. I will definitely talk more about this in the live streams that we have on Fridays. So for now, I think it's a bit late, and maybe it's better if we continue this in the live streams, if you are okay with that. But the main thing that I really recommend to you is to just try to sort the problems in Codeforces and try to solve them. That really helps a lot if you solve problems from around your own rating. And guys, if there's something that we couldn't talk in this session, you can always come and join our Telegram channel. Let me send the link of the Telegram channel again as all the other streams. You can join our Telegram channel and ask your questions there. If I see, I will respond those questions. I will try to respond all the questions. I hope that would work. Yeah, I will also try to make a DP problem, so that's okay. That's okay. So most of the things also about you, Vishal. Also, I really recommend you to sort the problems and try to start solving problems around your own rating, either your own rating or a bit higher than them. That is what I really recommend to you. But we will discuss it in detail in the next sessions for sure. And also in the Telegram channel, we can keep talking about this. So I will also talk about ICPC soon. There's also news. We are going to attend a training camp. I will let you know about it soon. We'll talk about it. So awesome, guys. Thank you again for joining today live stream. It was really nice to see you here, and I hope that you learned something and you enjoyed it. Again, if you want to support my work, I would appreciate it if you liked the video. Subscribe to the channel. I think that would help, but no pressure on that. You don't really have to do this. So if everything is okay, I think I'll see you in 2 days on the next contest, educational contest. Thank you a lot, guys. See you next time. Thank you. Thanks a lot. It was really nice to have you here today. See you. Bye-bye.